Welcome back to Math 109 Plane Trigonometry. In this video, we're going to take a look at how to solve an SAS triangle. So we're going to use the standard triangle that we've worked with. Triangle ABC, where the opposite sides are the lowercase letters of the angles. In this case, I'm going to tell you that angle A is equal to 42.3 degrees. Side B has a length of 12.9, and side C has a length of 15.4. So the first thing that I'm going to do here is I have sides B and C and angle A. So I'm going to use the form of the law of cosines of A squared is equal to B squared plus C squared minus 2BC cosine A. At this point, it's just a matter of plug everything in. Get A squared is equal to 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. Plugging all that into my calculator, I get A squared is approximately equal to 109.7. Taking the square root, A is approximately equal to 10.5, technically plus or minus 10.5, but it doesn't make any sense to talk about a negative length. So we can assume that A is positive. So now we need to find the other two angles. So technically we could do these in either order. We're going to take advantage of a theorem from geometry that says the order of the length of the sides is going to correspond to the order of the length of the angles, with the smallest angle having the smallest opposite side. So we need to know angle B and angle C. We see that angle B has to be smaller than angle C. Another thing we know is that we cannot have more than one obtuse angle in a triangle. Because if we did, we would have two angles of more than 90 degrees, which means they would have to add to more than 180 degrees. We know the angles of the triangle can only add to 180. So, at this point, we can use the law of sines to find angle B. So we know that side A is 10.5. Angle A is 42.3 degrees, so we need sine 42.3 degrees. And that equals the sine of B over our given 12.9. So we cross multiply, or actually what I'm going to do is go ahead and multiply both sides by 12.9. So 12.9 sine of 42.3 degrees over 10.5 is equal to the sine of B. Plugging that into the calculator, I get 0.8268 approximately for the sine of B. Which then, if I take the inverse sine, I get that B is approximately equal to 55.8 degrees. And we established that B has to be an acute angle. That is something you have to worry about when using the law of sines, because B could potentially be an obtuse angle and would still have a positive sign because the sign is positive in the second quadrant. That's why we picked the smaller angle. We know it has to be acute. So when we do this inverse sine, we know that that is the angle we're looking for. So now that we know two angles, we know that 42.3 degrees plus 55.8 degrees plus angle C has to equal 180 degrees. We go ahead and subtract the two angles from both sides, and we end up with C is 81.9 degrees. So that's how we solve a side angle side triangle. In the next video, we're going to take a look at how to solve a side 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 triangle.